So yes, my talk today. So the chat's been a little bit quiet. I've seen loads and loads of question and answers in the Q&A section, but I want you to have a little bit of a think, and if you're not brave enough, feel free to not use the chat and just write it down in your notebook instead. This thing here in the middle, what do you think that this actually is? To have a little bit of think, pop your answers in the chat section, or feel free to write it down on a piece of paper. Now, a bit of a clue here, it can be found in all of these different environments on the left. So top left, you've got someone's mouth, some really nice teeth. Underneath that, you've got a river environment. Below that, you've got your normal kitchen tap. And under that, you've got the most pristine looking social works I've ever seen in my life. Now, if you joined us on the Institute of Water sort of introduction to microbiology training session that we had sort of last week, I think it was, then you're a little bit ahead of the game. So what actually is this? So this is a biofilm under sort of a scanning electron microscope over at the University of Sheffield, and it can be found in all of those different environments. So when you're brushing your teeth in the morning and your teeth kind of feel like kind of sticky and kind of gross, it's normally actually that some sort of biofilm has grown up over the course of the night. So you've got microorganisms who live in your mouth, and they have reproduced and produced this like sticky spider's web of material that all sorts of things stick to. Now, it's the same in all of those different environments that I just showed you previously, including sort of that river environment, and also other places like inside your pipes that lead to the kitchen tap. So biofilms are essentially lots of microorganisms that come from the bulk water when they attach to different surfaces, as well as all sorts of basically the building blocks required for life. Things like carbon, things like phosphate that we've just been talking about, as well as a load of other things all combined together. So the project that I'm going to be talking to you about today, so I work with various different technologies, and I've got various different sort of projects going on in the UK. But the one that I wanted to most speak to you today, because I thought was most relevant, is the work that I'm doing with a SENTRY probe. And it's really, really interesting because, I don't know, I think Jo really set the scene earlier for exactly all of the challenges we have in the environment at the moment. So she's done an excellent job of sort of paving the way. And I'm here and I've got the good job, the positive job of being like, we got this, guys, we can get through this, we can do this. So thanks very much, Jo. So we have these sensors in various different water bodies. And normally when you have a sensor in a water body, if you just imagine it, for instance, in a river, things like algae will grow up on it. Or say if you have it in a sewage treatment works, you'll get like a nice growth over the surface of whatever probe you're using, say an ammonia probe or a DO probe. But this particular sensor is designed for the microorganisms to grow on the probe itself. So how it's really working here is when microorganisms reproduce, they produce electrons, which are normally sort of lost to the environment. The specific probe that I'm working with, just to give you a bit of background before I go on to some of these projects, it captures these electrons to give you like a quantitative measure of the microbial activity within a water body, whether that is a river or a sewage treatment works or a puddle or a swimming pool or a place of your choice. So that's what I've been sort of working with, one of my different instruments. So why am I actually trying to do this? So if you've not already noticed, I'm a microbiologist by background, so I'm super excited by all things micro. And I just feel like it's out there in all of these different environments. And some of our speakers today have touched on sort of the negative impacts of having those microorganisms in our environment. But at the end of the day, microorganisms are everywhere. You know, they live on your skin, they live inside your body, they're free flowing in the air, and most of them don't cause any harm to any people at any time. It's the vast majority of them are harmless. So actually, why not use these microorganisms that are naturally occurring to understand a little bit more about the water environments that are surrounding us? You know, because we're not going to achieve this place of complete sterile water environments. That's just not a possibility for us. They're literally everywhere. So instead, why not use these organisms to understand a little bit more about what's happening, and what can they actually teach us? What can they show us about different water environments? So one of the projects that I'm really keen on at the moment, and it's kind of in its early stages, but I really want to do more. And you know what Hugo was saying earlier about that sink or swim out was really exciting for me, because this is sort of where I want to go in future with some of the work that I'm doing. I'm really, really passionate about this. So we've spoken about CSOs quite a bit, you know, of these overflows into the environment. And I think it's so great at the moment how it's everywhere, all over the media, because, you know, like with issues like wipes and microplastics, I just feel like a lot of the work that we're doing at the moment, and a lot of the things in regulation, and you know, a lot of the grants and things I've been seeing coming up in the course of my career have been so much driven and so much motivated by the public and increased awareness that the public have in the environment. And so this is really exciting to me that people are interested in this specific issue, because this is something that's been going on for a really, really long time. And obviously it's going to continue to get worse in future with things like climate change, as we've just been hearing about. So for me, it's really exciting that people are starting to listen up and pay attention. And that's when I think the gears start to get moving. Quite a slow environment, I think, in the water industry, but things are slowly progressing, and things are, I've definitely seen since I've started in the water industry, that things are starting to move. So what I really, really want to happen in the future of water and the future of rivers is a bit like how speed cameras monitor the roads. I would really like to see water quality monitoring of that sort of scale monitoring our rivers. And I know obviously speed cameras, people are quite against speed cameras, and they're not always like the most positive reference to make. But if we can do it to the roads, why not do it to the rivers as well? So we can be looking at the microorganisms, you know, up and downstream, and seeing how these activity levels are changing over time. You know, I'm almost thinking on this sort of like thumbs up, thumbs down. Is there a lot of microbial activity in that particular river at the moment? Or actually, are the levels really, really low? And so that's just one thing that I'm really, really interested in sort of working on in future. Another piece of work that I'm doing an awful lot on in terms of microorganisms and what they're doing is early warning systems. So particularly for sewage environments, generally at sewage treatment works. So you can have all sorts of chemicals and things that can kill off microorganisms, creating like a toxic shock event. But equally, you can have things like, there's one particular site that I'm working with who have a big trade effluent from fruit juice manufacturer. And fruit juice, when they get manufactured, that it produces a lot of sugar, and there's a lot of sugar waste, which is an excellent food source for microorganisms. So water companies can take this evidence, and you know, if they have had problems, they can go back to the Environment Agency, and they can actually find out a little bit more, do a bit more of a root cause analysis almost of where these problems are coming from, because water companies are dealing with all of these issues, but they're really, really doing their best. And sometimes they've got such massive trade effluents coming in that's sort of beyond the capacity of a sewage works. So that's sort of like one piece of work I'm doing on the compliance piece, and a major part of the work that I'm doing actually. And then a final one, not necessarily all that relevant to what we're talking about today, but there's been so much work on sustainability that we've been chatting about, so I thought I would include it anyway, is the work that I'm trying to do surrounding energy optimization. So the theory behind this is microorganisms on a sewage work, you know, we're trying to keep them alive with things like aeration. Why not use the microbial load itself to work out how much aeration we need? Because essentially at the moment we're kind of over aerating our sewage treatment works. So it's about looking at the microbial loading directly, which is a little bit more real time than parameters like ammonia, for instance, and other parameters that we're using as almost like a precursor for what microorganisms are doing. So I've been really interested in this as well, and I think there's a good piece of work there. And again, something really people are very interested in, this net zero piece. So I'm looking forward to hopefully doing some more work in this sort of field in future. So yeah, what I'm trying to do with this system is I've got all of these different things that I'm hopefully going to work towards, both within river systems. I was just chatting recently about some drinking water applications as well, and treatment works fit into stage sort of sampling, and also within the sewage treatment works itself. So that's just one of the projects that I'm running at the moment. You might have seen Tom. I've seen Tom in the audience today. So I just wanted to do a bit of a shout out for the other people sort of involved in these projects that I'm working on. But yes, this has been my presentation today, all about using real-time, one reading a minute, microbial monitoring. So this device acts almost like a Fitbit for biology. So it's telling you the activity levels of the microorganisms within that river or within that water body, to understand a little bit more about the water sources around us, so we can start taking action based on what those microorganisms are showing us. And I've just come to the end of my 10 minutes. So thank you very much for listening to me today.